This video is on solving radical equations. So the method that you're going to use is you're going to isolate the radical, so get it by itself, and then you're going to square both sides of the equation. And that's how you're going to get rid of the radical symbol. So let's look at an example here. So give me 1 second. All right, so to isolate the radical, the square root of x, we're first going to get rid of the 7. So I see plus 7, so I'm going to subtract 7 from both sides of the equation. Now I have the square root of x equals 9. So once you have the radical isolated, the way you get rid of it is by squaring both sides of the equation. Remember, you can do whatever you want to an equation as long as you do it to both sides. And so whenever you take the square root and you square it, what you end up with is just the radicand by itself. So the square root of x times the square root of x would just be x. And 9 times 9 is 81. All right, and you can check this. So if you plugged 81 in, you'd have the square root of 81, which is 9, and 9 plus 7 is 16. So that is the correct solution. All right, so let's look at one more like that. So I'm going to isolate the radical by adding 5 to both sides. And so the square root of x, I don't know why I wrote a 5 there. The square root of x is equal to 3. We're going to square both sides. And again, squaring just means raise it to the second power. So I end up with x equals 9. And again, I can check that. Plug in 9, so the square root of 9 is 3, and 3 minus 5 is negative 2. So I know that I got the correct solution. All right, well, what if there's square roots or radicals on both sides of the equation? Well, we're just going to square both sides and get rid of the square roots or the radicals, and then we're going to solve for the variable. So when I square both sides, now I end up with 5t minus 11 equals t plus 5. So that just got rid of the radicals for me. Now I have an equation with variables on both sides, so I want to get them on the same side. So I'm going to subtract t from both sides of the equation. Remember, that's really 1t. So that goes away. 5t minus t leaves me with 4t minus 11 equals 5. Add 11 to both sides. So it's just a two-step equation at this point. I have 4t equals 16. Divide by 4. And t equals 4. And again, you can plug that into the equation and check it. So let's look at one more like that. So I'm going to square both sides to get rid of the radicals. So now I have 7x minus 4 equals 5x plus 10. Get the variables on the same side, so I'm going to subtract 5x from both sides. Hopefully I'm not going through this part too fast. I'm assuming that you've done a lot of solving equations if you're to this point. If not, you should go refresh on solving equations. So then I'm going to add 4 to both sides. So I'm trying to isolate the variable. And I have 2x equals 14. Divide both sides by 2. And x equals 7. All right, hopefully that's pretty simple. Let's see what else there is, though. Okay, let's talk about extraneous solutions. So sometimes when you square both sides of an equation, you'll get solutions that don't satisfy the original equation, meaning they're really not solutions. And these we call extraneous solutions, and they are not real solutions. So the only way that you're going to find out if a solution is extraneous or not is you have to check it. So whenever you're solving equations by squaring both sides of the equation, you always need to check your answers to make sure that you don't have any extraneous solutions or solutions that don't work. All right, so let's look at one of those. So here I'm going to square both sides of this. And so I end up with n squared equals n plus 12. All right, so I'm looking at a trinomial here. So I know that I'm going to solve a trinomial by factoring. So hopefully you've done factoring before. And so I'm going to move the n and the 12 over to the other side by subtracting them from both sides. And so I'm going to end up with n squared minus n minus 12 equals 0. And now I'm going to factor this, and what I'm looking for are two numbers that multiply to negative 12 and add to negative 1. So that would be 4 and 3. So 4 times 3 is 12. And since the result of the sum is negative, that means the larger number needs to be negative. So it would be negative 4 and positive 3. So this factors to n minus 4 times n plus 3 equals 0. So that means my solutions are n equals 4 and n equals negative 3. Now we need to check those. So let's change colors here. Let's check. I'll make this thinner. Let's check n equals 4. So we'll check that one first. All right, and you need to check both of them because it's possible that both of these are extraneous and then there's no solution. So we're going to plug in 4. So I have 4 equals the square root of 4 plus 12. So 4 equals the square root of 16, and that's true. So n equals 4 is a valid solution. So now let's check the other one. So let's check n equals negative 3. All right, so now I have negative 3, which some of you may already notice there's a problem here because the square root can never be equal to a negative number. The square root of something will always be positive. So I can already see this isn't going to work. And so then I have the square root of negative 3 plus 12. So negative 3 equals the square root of 9. So what we end up with is negative 3 equals the square root, negative 3 equals positive 3, and that means that's an extraneous solution. So draw a line through that, meaning not equal, and so that solution is extraneous. All right, so let's look at another one. So let's square both sides. So squared, squared. So negative y times negative y would be positive y squared equals y plus 6. Move these over to the other side. So I'm going to subtract y, subtract 6. So I have y squared minus y minus 6 equals 0. And that can factor to y minus 3 times y minus 2. So plus 2, sorry. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. There's a 1 in front of the y that's not written. So my solutions here are y equals 3 and y equals negative 2. So let's come over here and check. We'll check 3. So 3, make that thinner. And so when I plug in 3, I get negative 3 equals the square root of 3 plus 6. So negative 3 equals the square root of 9. All right, so I end up with basically the same thing I had above. I have negative 3 equals positive 3. So this one is extraneous. Let's check negative 2. So for that one, I'd have negative y, so that's the opposite of y, so that would be positive 2 equals the square root of negative 2 plus 6. So 2 equals the square root of 4, so 2 equals 2, which is true. So that's my one solution to that. All right, so last thing, if all of the solutions are extraneous, then there is no solution to the equation. So let's look at what that looks like. All right, so I'm going to subtract 8 from both sides. So I get 3y equals negative 6. Sorry, that's the square root of 3y. And now I'm going to square both sides. So I get 3y equals 36. Divide by 3. And y equals 12. All right, so now we're going to check that. Check. So I have the square root of 3 times 12 plus 8 equals 2. So that's the square root of 36 plus 8 equals 2. Can already see this isn't going to work. 6 plus 8 equals 2. 14 equals 2. So this is extraneous. Just put ext. And so that means there is no solution to this equation. No solution. All right, so if all of your solutions are extraneous, then there's no solution. So let's look at one more of those. So I'm going to subtract 6 from both sides. So I have negative square root of 2x equals 4. Now be careful here. I'm squaring the whole left side. So when I square this negative sign, a negative times a negative, it's going to become positive. So this becomes positive 2x equals 16. So divide by 2. And x equals 8. All right, so let's go check that now. Do a check. And so I have 6 minus the square root of 2 times 8. Sorry, that's 2 times 8 equals 10. So 6 minus the square root of 16 equals 10. And the square root of 16 is 4, so I have 6 minus 4 equals 10, which is 2 equals 10. That's not true, so this is no solution. All right, so that's it. So hopefully you are confident in solving radical equations now. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.